Hi, this is Mr. Bo from MrBoEnglish.com, and we are near the end of the quadratics unit in Khan Academy, and we've been going through practice by practice, learning why they work, how they work, and helping you finish them so you can get your percent. Because I know lots of teachers work the way I do, and you need to get that percent. So, last video we talked about the quadratic formula and how to do the solution, and this is the quadratic formula that we use. Today we're going to talk about the number of solutions and also about the axis of symmetry. So, get my pen here. That is really ugly. I don't have I have a one of these Intuos tablets, so I have to look one place and write another place. I'm not writing on the screen or anything, you know. So wait a minute. Here it is. So it's a difficult skill. I didn't think it would be so difficult. So, you know, if our parabola looks something like that, you know, we have our normal points that we think are important, which is the x-intercepts, and our quadratic formula will give us that. We have our y-intercept, and that's pretty easy to get because we just set x equal to 0. And if it's in standard form, then that's just c. Okay. There's the vertex, which is a really important point in a parabola, and line of reflection, axis of symmetry here, axis of symmetry, where these two sides are the same. They don't look the same here because I'm a terrible artist on this pad, but they're the same distance. So if this distance is 2, this distance is also 2, and if this distance is 1, then this distance is also 1. And if this distance is 1/2, what is this distance? It's also 1/2. So that's going to be important because you can see in our formula we have this negative b plus or minus this part here. So you can see if we look at the axis of symmetry, then the roots, the zeros, it's plus and minus. So this line of symmetry is actually at x equals negative b over 2a. And then we use this part here to add and subtract and find the zeros. Well, that's kind of cool. So if you have a standard form and they ask you where the vertex is, you can find the x really easily, and then you just substitute x and you find y. So that's good. And the other thing that we can do is what we're going to practice today, which is number of solutions of quadratic equations. And you can see if this is a positive number, positive real number, then we have 2. But if this, and I'm going to circle it, I'm not going to name it yet, is 0, then we don't have something that looks like that. We have our axis of symmetry, and we have our vertex, and plus 0 and minus 0, so those 2 points are really on the same point, and then that becomes our vertex, and it either opens up or down. Okay. And what happens if inside here is a negative number, so we don't know how to do a square root of a negative number then. Um, we'll get a parabola that looks like this. So we have three cases. One case is b squared minus 4ac is greater than 0. Greater than 0. This case, b squared minus 4ac is equal to 0. If it's equal to 0, then the square root of 0 is 0, and we just have this here, so we have only one point, and the one point is on the axis of symmetry. And then if b squared minus 4ac is less than 0, then we can't yet solve that, and we'll see there are no solutions. So that means that by looking at this part here, which is called discriminant, which is called the discriminant, this part right in here, not including the radical, not including the square root. If we look at the discriminant, we can tell if there are two solutions, or one solution, or 0 solutions. Okay? And that's what we're going to do today. So, today we're going to focus on the discriminant, and the discriminant is this b squared minus 4ac part. So, let's get started. All right, so we have to look here and remember that if b squared minus 4ac is greater than 0, we get two solutions. And if b squared minus 4ac is equal to 0, then we have plus in our quadratic formula. We have a plus 0 and minus 0, so we have only one solution. A 1, not an L. Okay. And if b squared minus 4ac is less than 0, then we get a square root of a negative number, and we really can't do that yet, so we're going to get 0 solutions. Okay? So let's look at our picture over here. Question is the discriminant of g is our function here, g of x, positive, 0, or negative? Well, we have to look at how many x-intercepts it has, how many zeros it has. It looks like it has 1. From the picture, it looks like it has 1. And if there's one solution, then I know the discriminant is 0. So I'm going to choose that. Okay, so here we have two questions. What is the value of the discriminant of f? And then how many x-intercepts does the graph of f have? So what is the value of the discriminant of f? We need to do the same thing we did before, put it in standard form, find a, b, and c. This is already nicely in standard form. So a is equal to -4, and b is equal to 12, and c is equal to -9. Okay, and b squared, 144, is 12 squared, minus 4 times -4 times -9. And let's see, I've got those are going to cancel out. I still have a minus here, so 36, 120, 144. 144 minus 144. So the discriminant is 0. So the value of the discriminant is 0. Now let's look over here. If the discriminant is greater than 0, we have 2 solutions. If the discriminant is equal to 0, we have 1 solution. If the discriminant is less than 0, we have 0 solutions. So we have 0, so we're on this case right here, case 2. So we have 1 solution, and it's 1 solution. Is the discriminant of f positive, 0, or negative? So let's look at the number of solutions, number of x-intercepts, and I see I have 2. For 2 solutions, I know it has to be greater than 0. I know it has to be positive. And our last question here, what is the value of the discriminant of f? How many distinct real number zeros does f have? So what is the value of the discriminant? Let's find that. This is already nicely in standard form, so I can just find a equals 1, b equals -3, and c equals 18. And my b squared is -3 squared minus 4 times a times c. So now I have 9 minus some big number. What is it? 72. Okay, but this is definitely a negative number. So let's see. Oh, I have to find it. I actually have to find it here. Okay, so it's -63. All right, so our value of the discriminant is -63. And how many distinct real numbers does it have? Well, we find that 63 is less than 0, so it has 0 solutions. And we're done. So I hope that helped you. If you need any more help, the discriminant is not clear. Get a hold of us at mrbowenglish.com. Mr. Bo English รับสอนนักเรียนตั้งแต่ป .3 ขึ้นไปทางอินเทอร์เน็ตในสไตล์ EP ครับ ผู้สนใจช่วยติดต่อครูแจงหรือไปเว็บไซต์ที่ www.mrbowenglish.com